Today I discuss this monkey and the hunter problem, a famous problem in the study of projectile motion. This problem will illustrate the importance of the frame of reference in solving the physics problems, especially the mechanics and kinematics problem. This states a hunter spots a monkey hanging from a tree branch, aims the rifle directly at the monkey and fires. The monkey, hearing the shot, lets go off the branch. At the same instant, the hunter fires the rifle, hoping to escape by falling to the ground. Will the monkey escape? Neglect air drag. Well, this figure will help us understand the problem better. If we want to solve the problem from ground frame, we must consider a XY reference frame as is shown in the figure, with origin at the point from where the bullet is fired. The initial coordinate of the monkey is x coordinate d, y coordinate h. If the bullet, the line of firing makes an angle, say theta, with the horizontal, then h by d is tan theta. Yes, we can write h by d is equal to tan theta, where theta is the angle of projection of the bullet. At any instant t, when the x coordinate of the bullet is d and y coordinate is suppose y, then we write d is equal to u t cos theta, where u is the initial velocity of projection, y is equal to u t sin theta minus half gt square. These are the coordinate of the bullet at the tth instant, and at that tth instant the monkey, as he starts from rest, has descended by a distance y1 suppose, which is equal to half gt square. If we can prove that y plus y1 is equal to h, then we can declare that the bullet strikes the monkey. And if y plus y1 is not equal to h, then bullet misses the monkey. Well, as you understand from all these equations that it involves a lot of mathematical calculations to eliminate the different unknowns that we have assumed to define the problem and to get the final relation of y plus y1 and check whether it is equal to h or not. But if we change our reference frame, we can see that with a new reference frame, we can work out the problem very easily. In any reference frame, when we discuss a problem of kinematics, The two initial questions to study the motion is important. The number one question is initial velocity, that is magnitude and direction of the particle, and number two is the acceleration of the particle subsequently. If we have these two vectors defined, then we can find out the subsequent motion of the particle very easily by drawing the kinematical equations. Now, that is what we had done here earlier when we took the reference frame fixed to the ground. If I now change the reference frame fixed to the monkey, suppose I take my reference frame, the monkey. Mind that whichever object I take the reference frame, that object is stationary in my frame. When I take the ground as reference frame, ground is stationary. When I take monkey as reference frame, then monkey is stationary in my reference frame. And let me define from this reference frame of monkey the initial velocity and acceleration of the bullet. Well, as monkey observes, the initial velocity of the bullet has a magnitude, say u, as we had done earlier, and directed along the line joining the nozzle and the monkey. This is the initial velocity, magnitude and direction as observed by the monkey, our reference frame. And what about the subsequent acceleration of the bullet as observed from this frame? Well, from ground frame, the bullet has acceleration g downward. As the monkey is falling freely from ground frame, the acceleration of monkey is also g downward. And therefore, from the frame of monkey, the acceleration of bullet, well, as we know that relative aspect, that acceleration of bullet with respect to monkey, this vector is acceleration of bullet vector with respect to ground minus acceleration of monkey vector with respect to ground. This is the relative vector as is well known to us. From this, we get that since both this acceleration of bullet is g downward and that of monkey is also g downward, so acceleration of bullet with respect to monkey is 0. That is, from the frame of the monkey, the bullet has no acceleration. And if an object has no acceleration but initial velocity, then obviously it is moving in a straight line in that frame. So the monkey observes that bullet is moving in a straight line. And what is the direction? Well, the direction was initially along the line joining the nozzle and the monkey. So the direction of the bullet remains same from the frame of the monkey. Monkey always observes that the bullet is moving towards it. And so, finally, the bullet hits the monkey. The monkey cannot escape. So by changing the reference frame, we could answer the question very easily without any detailed calculation. Our key point was that our reference frame we took as monkey. He observes that the bullet starts moving towards him and it has no acceleration. So the bullet continues to move towards him. in his frame and ultimately hit him. This is the importance of the reference frame. Well, in my long teaching career, I had immense pleasure in discussing this problem with my students who generally did not care much about the reference frame. But this problem could teach them how a reference frame, suitable choice of reference frame, helps solving the problem very easily without detailed calculation. What you have to consider is a proper reference frame to solve a particular problem. Thank you.